So just a quick update. I've built up this portion of the circuit here from the just after the electret microphone, the low pass filter here, the NE612, the 10 megahertz oscillator here, and then I'm sampling out here. So I've got, so basically what we're going to see is I've got a 2 kilohertz signal injected from my signal generator. So you can see here, 2 kilohertz coming in at half a volt. And then that is being mixed with the 10 megahertz oscillator set up here. And what we should see on the sampled output here is a whole pile of harmonics that are the 10 megahertz signal plus the 2 kilohertz minus the 2 kilohertz, and then a lot of the integer multiples of that. So that's very hard to see on an oscilloscope. Basically, you'll get a sine wave that looks like it's around about 10 megahertz, but it will be quite distorted. So the best way of seeing that is through the spectrum analyzer. And here it is here. So you can see here I've got, this is the 10 megahertz center frequency here. And you can see as I move the marker, I've got a whole series of harmonics there. So there's the first lower harmonic, and that's at approximately 2 kilohertz less. So moving down a little bit further, another 2 kilohertz, and so on and so forth. So each one of these is separated by 2 kilohertz. So obviously what we're trying to do with the crystal filter is basically filter out all this stuff. What we want is basically this single upper sideband signal here, and that's what the crystal ladder filter will do. So just panning back to the circuit so you can kind of see the PCB that is set up here. Got a bit of glare from the screen there, but that's okay. One of the things I did with this, I actually, instead of printing it out, normally I print it out mirrored. So this actually should be on the bottom, but it's usually you have the traces on the bottom of the board. But anyway, makes soldering a little bit more difficult, but that's all there is. So just walking you through there. So this is the electret microphone that actually goes here, passes through a capacitor. Here's the low pass filter. Here's the NE602 mixer, and then this is a crystal 10 megahertz crystal. I have a variable cap here, which is used to adjust the frequency of the 10 megahertz crystal. And then on pin 4, I'm getting the output, goes through a capacitor, and then I'm sampling of that output there. And this part of the circuitry is just the 8-volt power supply. So anyway, the next step, I'm going to put on the crystal filter, and we'll compare and contrast the signal after the crystal filter. And what we should see is all those harmonics except for the upper sideband 2 kilohertz signal, or 10 megahertz plus 2 kilohertz signal. That's all that we should see. So that's to come in the next video.
So I thought what I'd do next is do a little bit more experimentation with the crystal ladder filter itself and show the results on the spectrum analyzer. So in order to do that, I'm going to basically take the schematic for the crystal ladder filter out and create some boards that just have the crystal ladder filter on it, and then do the experimentation there rather than doing it on the board. So I thought it'd be a good opportunity to show at least how I use Eagle and the Fab in a Box PCB kit. Might be of interest to some people. That it's a pretty straightforward kit, but there are a few tips on there that can help dramatically improve the quality of the output. So obviously step one is the board itself, and I've got that up here in Eagle. And kind of the first thing you do with that is you just want to hide all the layers that you don't need. So I don't need anything but the top and the pads. So let's put that back in. So top and the pads are all we're going to be printing out. And then when you print that out, I've got my printer turned on over to the right here. You'll see that it comes up now. Because I want this on the bottom, so the traces on the bottom, I want to make sure that I have mirror unchecked, and obviously all the mirror rotate upside down and so on and so forth unchecked. So if you want the traces on the top, you print it off in mirrored. If you want the traces on the bottom, you disable mirror. So let's get that printed off. And what I generally do is I print it off on a blank sheet first, and then I sticky tape the results to the I sticky tape the transfer paper on top of that and print it again, so it gets the orientation right. And I'll show you that. So let's just print one of those off. And the lights always flicker when I actually do the printing here. Here it comes. So here's the result printed off here. And what I'm going to do now is I'll just pause the video as I'll sticky tape the transfer paper on top of that and then come back to you. So here's the transfer paper, the blue transfer paper, sticky taped over the top of the image there. And I just put that back in the printer with the same orientation. I actually, before I print it out, I just put a little arrow down the bottom left, so I know when I'm printing it off which side should go up. So let's put that back in there. And one of the things you've got to make really sure is that you keep your fingers away from the paper itself. Any touching of the paper, transfer of oils from your fingertips onto the paper will mean you won't get a good image. And even when you don't do that, there's no guarantees of a good image. This is not a hugely great quality laser printer. So here's the result printed on the transfer paper there. There is a little bit of a smudge right about here on the paper, but that's not going to affect any of the traces. So I'll move out to the garage where I've got the transfer iron itself all set up, and we'll come back. So here's the laminator itself heating up. This was, I kind of bought this all from the Fab in a Box link, and I'll put that down below. So they sell the transfer paper and the laminators and a whole pile of stuff. So it's a good little kit. I've had a lot of fun with it. But basically what you have to do is you set this on maximum heat, and then you've got to wait 20 minutes for the rollers to heat up. And I've really tried this. You really do have to wait that 20 minutes. If you try and do it when it's not completely heated up, the toner won't affix to the PCB board, and then you'll have to start all over again. So we'll give this 20 minutes and come back when it's fully heated up, and then we'll put the transfer paper and a board through there, and we'll take it from there. So I've cut off a piece of PCB that I'm going to transfer the toner to. Here it is here, and as you can see, it's actually quite tarnished. So one of the things you really have to do is clean up that PCB as well as you can using either acetone, isopropyl alcohol, or something like that. The last thing you want is to have again finger oil on the PCB itself. So I generally use acetone and steel wool to clean that off, and that seems to work reasonably well. So I'll do that now. Just clean that off. As you can see, that tarnish is going now. And then kind of the final piece is to
dry that with a as clean a cloth as you can get. Use this this cotton here that comes with some gun cleaning kits, so it's come in handy. Alright, so that's kind of as clean as I can really get it, and now we have to wait for the laminator to heat up. So we'll be right back when that happens. Okay, so we have the laminators heated up right now. So the next step is to put the PCB through. So I've drilled a little hole in you can see it right there. That's for the step where we actually are etching it. So you don't need any sticky tape on this. It'll basically, make sure we're in camera here. It'll basically affix the on the first pass, so you really don't have to worry about it coming off. And what I like to do is run this through 6, 7, 8, 9 times until it's I guess done. It's you can't really tell when it's done. You just got to keep running it through until until you think it's affixed enough. You can see there straight away it's already stuck pretty well down there. But you just run this through, like I said, I generally do 8 to 10 times through. And then the next step after that is to put it in a water bath for a couple of minutes. So we'll come back once it's ready to be put in the water bath and take it from there. Okay, so we're on the last pass through here. I think I ended up doing 8 times, doing it in different orientations. And now you simply drop it in the bath of water and wait a couple of minutes. At that point, and this is the great thing about the Fab in a Box kit, is you can do this all with just glossy paper and putting it through the printer, but the Fab in the Box, there's a special starch-based adhesive that's on the blue transfer paper that basically allows it to lift off. Without that, it's a pain. I've tried sort of doing homebrew equivalents to this, and it never worked out that well. So we're going to keep the laminator going because there's a further step where we apply the green transfer paper, and I'll show you that next. That's coming up as soon as we have the transfer paper off the PCB. So that's coming up. Okay, it's been a couple of minutes, so moment of truth here. Now this, you don't have to do anything really special. This just lifts right off. And there's the almost finished product. We've got a few more steps to go. The important next step though is, and that's actually turned out pretty well, there's that little smudge that was on the laser printer, so sometimes that's unavoidable. But the next step now is to give this a hard wash. You have to basically, if you can see, there's a residue that the transfer paper leaves on there that you need to get off in prep for the next step, which is the green transfer paper. So what I'll do is I'll take that over to the sink in the laundry, give that a hard wash, and we'll be back straight after that. Okay, we're back from the hard wash, and you can see that's gotten rid of all that residue from the blue transfer paper. So before putting on the green transfer paper, I want to sort of get this all dried up, and to do that I'll do this off camera, but I have I guess it's a heat gun. I used to do RC. I don't do RC planes. I don't do much of that anymore. But the heat gun was from when you put the paper, not the paper, the covering on the wings for the plane. So it's come in handy for electronics too. So it's always good to have this sort of stuff standing by. So if we have a look now, that's perfectly dry and is good to go to the next step. So on to the next step, and this is where this green transfer paper comes into play. So basically with the laser printer toner, it's actually quite porous. So if you just use the laser printer toner, what you will get is you'll get basically an etch through on the board, which is no good at all. So basically what this green transfer paper does is it applies a layer on top of the toner, which is not porous to the etchant. So basically that will give you it'll allow you to have finer traces, and you won't get kind of intermittent connections because the etchant is partially eaten through your traces. So unfortunately this stuff is kind of fiddly, and generally how I put it through is you do have to kind of affix this some way to the back of the board. So just let me get that to size. And then once you've affixed it, it's a simple matter of putting it through the board. Now you have to hold it, otherwise you will get, and I've actually got some kind of I guess folds in the paper itself. So you don't need to put this through too many times. I usually do once or twice with the green transfer paper, and then it simply lifts straight off if it's worked right, of course. So we'll see if that's happened. So this stuff is painful. I've had a few times where I either haven't cleaned the board well enough, or the paper's wrinkled and I've had to start from scratch again. So, but when you get it on, it does produce a good result on the board. I've tried a few different ways of putting this on. It's just a little bit fiddly. So that's enough. We've gone through twice there. That should be enough. So this is gonna be all on camera. You'll see the result for yourself. And you can see there I've got a few folds in it. This board is rather hot. So let me pan the camera down, and you'll see it at the same time I see it, how well it's come off. Oh, I've got a bit of light on that. Let me get that out the way so you can see it a bit better. Sorry about this. I got some powerful LEDs above it. So which one's that one? There we go. Let me move that one out the way. So as I lift it off, my hand's got a shadow there now. So you can see there that's actually come off reasonably well. Yeah, that looks okay. You can see there's a few places where I've had folds in the green transfer paper. There's one right here, but that's not too bad. It's not actually on a trace or anything. This is obviously this is in reverse, so anything with green will be preserved when I put it through the etchant. So that's come off. That's come off kind of okay. And one thing you do have to check for is on this is anywhere on the board where the transfer paper has attached where it shouldn't attached, and you can fix that afterwards. But anyway, so anyway, this whole thing it might seem a little bit fiddly, but I kind of like doing it because I certainly could send these boards off to get printed, but I like to experiment with these boards myself, and I can't afford a couple of day wait on every board I want to do. So this is fun. The materials themselves, again, I'll provide a link below to all the Fab in a Box materials. Materials themselves are quite cheap. I mean, I've now bought two sort of complete sets of the blue transfer paper and the green transfer paper, and they have lasted me forever. So it's not something you go through quickly. I mean, you're not going to be making, if you're making hundreds of boards, you'd use a professional outfit. I'm not into making hundreds of boards though. So anyway, the next step is to actually pop this in the etchant bath, and when I've got that set up, I'll come back. So I'll probably have to talk up over the noise here. So this is the messy and unpleasant part of the operation, and basically what we have to do now is put it through the ferric chloride etchant. And ferric chloride is extremely unpleasant stuff, and this ferric chloride solution actually has hydrochloric acid in it as well, so it's corrosive. If it gets on clothes or concrete or anything, it will stain it. So you can see, let me pan down onto the desk here, it's stained all the wood there, so unpleasant, and if there were a better way of doing it, I've looked on YouTube and I haven't seen any better solutions. So there are solutions that do it a little more slowly. They're a little less, but they take forever. Anyway, so this particular setup here, I got this off Amazon a while back. It's got a fish tank aerator and a heater, which greatly improves the speed at which the board is etched. So just put that in there and kind of put the lid on top so it doesn't splash everywhere, and that's the process of etching a board. And obviously when you're done etching it, you have to drill all the holes. So that's kind of an end-to-end process of etching the board with the PCB with the Fat in a Box kit. Like I said, I'll provide links below to the materials, and that's all for now. Okay, talking up again, I think we might be done here. So let's bring the board out, and obviously the thing to check for is to make sure that there aren't any remnants of copper left on the board itself. So sorry, I've got that out of focus here. So the test is generally seeing through it. I think we might have some copper remaining on the board there. Let me just rinse that off a bit and then see if that changes anything. There's a few little bits of copper left on there. We really only do need a. No, I think that's good to go actually. Yeah, that's good to go. So kind of next step is to basically clean off the green stuff with some acetone, and then we'll be good to see the final product. So there's the finished undrilled product there, and you can see that the traces have come out quite well there. There's no bleed over of there's a little bit of incompletely etched copper right here, and there's another little bit up here, but generally this is kind of good to go. Couple of things I forgot to mention. One of them is with the laminator itself, what you have to do is, after you're finished with it, turn the temperature down to minimum and then leave it for 20 minutes. If you don't do that, you'll end up with flat spots in the rollers, which is no good. So that's been kind of going for 10 minutes or so, another 10 minutes, and I'll turn it off. One of the other things too is as you're sort of going through the etching process, you got to make sure that that etchant doesn't get anywhere near this board after you've cleaned the green the green transfer paper off it. It will etch immediately into the board, and you'll have to start all over again. The other thing too is I should really wear gloves on the etching process. That stuff isn't good for your fingers. Isn't good for anything really. I actually spilt a whole pile on accidentally on the garage floor here, and that was about a year and a half ago, and the stain is still there and won't go. So that's the process of etching. I'll go on to sort of drilling all the holes there. That's pretty straightforward. I got a press drill there. I've tried with hand drills. It just doesn't, I can't do it with a hand drill, so I got a cheap press drill a while back, and that seems to work pretty well. So anyway, that's making a PCB. What I'll do is I'll probably close up the video at this point, and then in the next video I'll put I'll basically create some crystal ladder filters on this board, and then we'll put the signal through the signal analyzer, and we'll see how that bandpass, how well that bandpass filter actually does. Anyway, that's in the next video. More to come.